Okay, so you may or may not have heard this word before, but we're going to talk about what a function is, okay? And to start by talking about a function, we're going to compare two different graphs today. So on your paper in your notes, I want you to create two tables. We're going to use them vertical. Sometimes kids will call them T-charts. Our X and our Y is always here and there, okay? And the difference between these two tables that's going to help us learn about what a function is we're going to say this first table is going to represent the whole class, Mrs. Z's whole second hour right now. And if I'm going to make my age be my X value, and my Y is going to be my height, so my age is my independent variable. As Ms. Larson talked about that with you, independent. Okay, so which one depends on which? Your height depends on your age, right? Okay, so let's just go, if I were to go up and down the aisles, which I won't, we're just going to create this. So let's say there's a 13-year-old, and then I say, okay, how old are you? Let's measure you. You're 58 inches tall. This kid's 12 and is 55 inches tall. This kid is 14 and is 60 inches tall. There's a 12-year-old who is also 60 inches tall. And then we got an 11-year-old who is 51 inches tall. Okay, so let's say that's the data that I gathered when I went up and down the rows asking for information, okay? And as I looked at this, I see a couple different things. I see that there are two 60s in the Y column. See anything wrong with that? No. It just means what? That there are two kids who are the same height. No big deal. That's allowed to happen. It happens a lot, actually, right? I see two 12s in the Y column. See anything wrong with that? No. In this particular table, it just means that there are two kids who are the same age. And that happens a lot, especially in an 8th grade classroom, right? So there's nothing wrong with either one of these. It's the wind. So having two Y's that are the same, having two X's are the same, that's okay. So we're going to call this data a relation. Okay? So this data represents a relation because there is a relationship, do you agree, between age and height? Okay? Let's kind of do a little side note for a minute, just for the heck of it. Let's see what the relationship between age and height is. So if I were to take a graph, and I only need the quadrant 1 because you can't have negative age, you can't have negative height. So if this was your age, we're going to keep it simple, and this was your height, and this went by years. Usually when you're born, you're between like 19 or 22 inches, 8 or 9 pounds, 7 pounds. So let's say you start right here. So let's say your birthday, the day that you're actually birthed, is 0. So let's say this is 1 foot, 2 feet, 3 feet. Let's say this is a short baby. So we're not using numbers for sometimes. It's a very short baby. So sometimes you'll talk about graphs and the shape of them without axis labeled even. So what happens as you grow? At 1 year, as your age increases, your height increases. Now, do people grow in at different paces? Yeah. Some people may grow slower. This person may grow faster. But we're going to look at this black line right here. So what happens eventually? Is this going to keep going? Is it okay for me to put a little arrow right here? Are you continually growing? Think about the cycle of growing. Like, I don't know about you, but from the time I was a junior in high school, I have been 5'4". I've not grown in many, many years. So what happens eventually to your height? It stops and it stays the same. So what would that look like on this graph? We'll get to that next. So at some point, do you agree that your graph kind of starts to look like this? Which means that your age keeps going. Believe me, I wish there was a way to stop the aging process. Okay, so your age keeps going, but what stays the same? Your height. So let's say I stop at 4, 5, 6 feet. This person stops growing and they're 6 foot tall. Then one can argue, like Maddie said, that when you're 95 years old and you've been walking around the planet for 95 years, your bones start to condense and you shrink a little. You ever going to go back to being 2 feet tall? No, probably not. Okay, so is this line going to be as drastic of a line as this one is? No, it might be very, very gradual. Okay? So if I were to give you this graph without even numbers here, with just the word age and height, would you be able to interpret that? Because that's what we're going to kind of be looking at on our learning target number 8 coming up, or 7. So you're growing, you stay the same height, and then eventually you start to kind of shrink a little, I guess, for lack of a better word. Okay. Do they always? I don't know. It depends on how strong their bones are, how much they took care of their bones when, how much milk they drink. Okay, so does everybody agree that this is a relation? There is a relationship between age and height, right? Okay. I am going to tell you, though, that this data does not represent a function. It's not a function. We're going to find out why in a minute. Okay? Because part of your learning target today is going to be answering yes or no. I'm going to give you a table. I'm going to give you some points. I'm going to give you a graph. And I'm going to ask you, is this a function or not? And all you have to do is say yes or no. Seriously, this is like one of the easiest things. Okay, so let's take this little guy right here, this 11-year-old, and let's give a whole table just to him. So let's just say this is Joe. I always use Joe every year. So this is Joe's age and Joe's height. And when he was 11, he was 51 inches tall. And when he would turn 12, and this, by the way, this is to be on his birthday. Does anybody still have mom or dad who like do their, I still do the height charts that like draw on the wall or something? Yes, I know, we do it. Just do it for us. So on your birthday, this isn't like, because technically you can be 12 like 365 days a year, right? So this is not me measuring you. So just for the sake of argument, we're going to say that. So on your birthday, when you turned 12, you were 54. You grew 3 inches. So the next day on your birthday, you just had a little growth spurt, didn't grow that much. Then when Joe turned 14, he had a big growth spurt, grew 5 whole inches. He did some new pants. 15th birthday, he had not grown at all because he grew so much the previous year. Okay, so let's stop for a second. And now I want you to look at the fact that it just so happens to be that it's the same number repeating. Nope, it's just a coincidence. Do you see anything wrong with having 2 60s in this height column? Is there anything weird about that situation? No. Because he just didn't grow 1 year. That makes sense to us, right? Okay? What wouldn't make sense? So if I were to say that, what's weird about that? What's weird about having 2 15s? Now you know why I said it had to be on his birthday, because it wasn't like in May of his birthday and then the next, July. So what's weird about that, Anastasia? Right. Believe me, if there was a way to figure out how many times has your mom celebrated her 29th birthday or her 39th birthday, right? That's the joke. Every time there's a big milestone, 29 again. So, as much as we would like this to happen, it's not. It can never happen. We can't change that. So, the fact that I have 2 repeating x values is not okay here. So, I want you to kind of write over here, was it okay to have 2 y values be the same? That made sense still, right? So it's okay to have 2 of the same y values. It's not okay to have 2 of the same x values, meaning no x's can repeat. So I crossed this point off. And because I'm not including this point anymore, I am able to call this relation a function. So this is a yes. This one's a no. Okay, so I'm going to firm up for you why that is in a minute. So the function has to do with the x values. If any of your x values repeat, it's instantly not a function. It's just a relation. Can your y values repeat? Sure, just not your x's. So here's what I want you to write right here. If there are no repeating, meaning 2 of the same, x values, then yes, that's a function. The minute there are more than 1 of the same x value, it's just a relation. So a function is kind of like a stricter version of a relation. So each of the x values can only be paired with one of those there. Okay. So let's talk a little bit more about that. So that was your table. Because I'm going to give you 3 things today. Table, points, and then graph. So I'm going to give you all 3 of these today. And you have to be able to tell me, yes, it's a function, or no, it's not. Do you think that you're okay to tell it on a table? Just look at the x's. If you see some repeats in the x, no, it's not. Okay, so what if I gave you some ordered pairs? Probably even easier. Like what if I just said to you 8, 7. Let's put this up here. 2, 1, 3, 9, and 0, 9. Is this a function, yes or no? So what would you look at? I'd look at just the x's. I don't care about the y's. We already saw that it's okay for the y's to repeat. It makes sense when the y's repeat. It doesn't make sense when the x values repeat. 8, 2, 3, 9. Is this a function? Yes. Okay? There's 2 9s though. It's okay. So this would be a yes. There will be times where I ask you a question and I'll do this and I'll say, give me a value for x that would keep this set of data a function. So what number could I put in for x if I still wanted this to represent a function? I could put in anything except 8, 2, 3, or 0. Any other number, and you're okay. What if I change the directions and say, okay, put in a value for x that would make this set of data not be a function? How many choices do you have? 4, 8, 2, 3, or 0. Do you understand? Okay, so it's all about the independent variable, the x value. If there are repeats, not a function. Okay, now, graph is a little different. Graph is a little trickier. So I'm going to get some graph paper and show you that. So on a graph, if I were to take this right here and ask you, is it a function? You would probably say no, because there's a very common misconception with functions. Does a function mean it has to be a straight line? Let's revisit real quick what a straight line means. Straight line means it's linear. Linear means constant rate of change. Do you remember that from last year? This is like all of trimester 2, linear. You know what linear would mean? It would mean for every year on his birthday, this kid grew exactly the same number of inches each year. That would be kind of creepy. That would be like The Giver. If anybody ever read The Giver, where they're like, okay, you'll read it. When you read it, this comment will make sense to you. So like every year, they grew exactly 2 inches. So this would be 51. This would be 53. This would be 55. That doesn't happen. We don't grow the same amount each year. That's not linear, right? Sometimes we grow more than others. Sometimes we don't grow at all. So this isn't linear, but it's still a function? Yes. So please don't confuse being a function with it being linear. I'm going to tell you that this is yes. And here's why. Because if I were to name all those points, what would I find out about the x values? There would be all different, right? Because the x value here is, the name of this point is 0, 4. The x value here is 1, 2, 3, 4, 6. The x value here is 5, 6, 7, 8, 9. And the x value here is, what is this? Where are we at? 6, 7, 8, 9. 9, 6. Okay, well, let's look. 0, 4, 6, 9. Is it a function? Yep. Okay. There's a shortcut for you to be able to tell that. You're not going to have to label those points every time. What if I just flip this upside down and use this? What if I said here, 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 here? Do you think that's a function? Why or why not? And tell me, which 2 points are you looking at that really, it's either these two or these two? Which 2 do you think means all bets are off, Autumn? The ones that are going up and down. Here's why. Because the name of this point is 0, 3, and the name of this point is 4, 3, which means both of the y's are the same, which is okay. But when she looked here, this is 4, 5, 6, 7, comma, 1, 2, 3, 4, 5. And this was 7, comma, 7. So guess what? You have 2 7s, which is not okay. It's still a relation. It's just not a function. Got me? Okay? So there is something, believe it or not, in algebra in the functions unit called the vertical line test. And it requires you to be able to draw a straight line up and down. And if you can do that, you'll be okay. Which means if I were to just draw a bunch of straight lines, how many points fall on each line? Actually, let's do this one first. Draw a straight line. Draw a straight line. Draw a straight line. How many points are on each line here? Just 1. And that's why it's a yes. Because that's all you can have in order for it to pass the vertical line test. So when I'm drawing my vertical lines here, I'm good. I'm good. Oh, I got 2 on one line. This is a fail. It failed the vertical line test. This is not a function because of the vertical line test. Do you understand? So you don't have to go ahead and write the points out each time. Okay? So I want you to kind of put a little arrow here, and whatever you need to do from graph, put, does it pass the vertical line test? Meaning, you can only have 2 points, I'm sorry, not 2, 1 point per line. You can't have. Sometimes I'll say what it can. And so you can only have 1 point on each line. Otherwise it fails and it's not a function. Okay? So learning target 1 is I can identify a function from a table, from 2 points, from a graph. Are you good on those 3? Okay? Because we're going to move into learning target 2 right now.